Next we'll see central processing unit. And here is the first one, stack operations. So everyone knows about what is stack. Stack is a last in, first out. So here, so we'll see the operations, stack operations. So there are two main operations. One is push operation, another one is pop operation. Push in the sense we are adding the data into the stack. Pop in the sense we are just removing or taking out from the stack register. Stack. Okay. Yes. Now here is stack pointer is another one. It is pointing the stack. Stack is nothing but a small memory, and memory. So there are memory locations. So it is counting from the bottom to top. So bottom, if it is 0, bottom is 0, first location is 0, then the next one is 1. It is incremented by 1. So when it will increment while pushing the data, so the position of the stack will be incremented by 1. Pushing in the sense writing into the stack. So pushing, writing or keeping into the stack all are same. So while pushing into the stack, so the stack pointer is incremented by 1. If it is the last location is assumed to be 0. So normally the last location is the highest location. Then if it is the highest locations, then while pushing the data into the stack, so for every push we have to decrement the stack pointer by 1. So if it is assigned the last location as the bottom location is the 0, then while pushing the data into the stack, you have to increment the stack pointer by increment it by 1. SP is equal to SP plus 1. Okay. So now the stack pointer is pointing the first locations in which you are going to push the data. So how to push the data? The data is available in DR. So now it is transferred into the stack pointer. The stack pointer is pointing the address, so in which the data will be stored, and this can be specified as M of SP. So increment the stack pointer by 1, then you push the data into the stack, and every time after pushing, suppose the maximum location is if it is supposed to be 24. So while incrementing 24, it is not 25, it becomes 0. So while pushing the data, so it is moving on, it is goes on incremented by 1. When it reaches the topmost location, the maximum location, after incrementing, suppose the maximum location is 24. 0 to 24 means, so next increment by 1 is not a 25, it becomes 0. Again, it starts from the beginning. So we have to check if the stack pointer is 0, then automatically meaning what? The stack is full. Full in the sense if it is pointing 1. Okay. So else means empty. Full is empty is 0. So so then after there is some locations to fill or to push the data. Okay, and this is the meaning. Okay, and this is for pushing the data. The next is pop. Pop every after pushing the data. So we have to decrement the data taking out. After taking out, you have to decrement the data by 1. So after taking out, then you decrement the data by 1. So taking out in the sense what? From stack pointer to data register. Okay, so M of SP to AR, then you decrement the stack pointer. At one time it will become, so while goes on decrementing the data, one time it will become 0. So if it is 0, then the stack is empty, otherwise full. Empty is 1, full is what? Automatically what? 0. So full is 0 means it's not at full. Empty is 1 means it is now empty. Okay, and this is for pop in the sense you are making empty. Push in the sense we are making full. Okay, and this can be implemented. The stack operations can be implemented by using this reverse Polish notations or PN. So normally any expressions can be written as like this, A plus B. And here for stack operations, this can be transformed into either prefix notation or postfix notation. Prefix or Polish notation, postfix or reverse Polish notations. For example, this is an equation, A plus B, A star B plus C star B. And this can be written using Polish notation. As Polish notation means, so suppose this is to be, of course, A star B in the sense, Operand first, operator is next. If the operator is next to the operand, means it is postfix. If the operand is pre assigned, you are specifying pre to the operand, then it is prefix. So here, so A star B means AB star. Then C star D means CD star. Then after that you just add these two contents. So you put a plus here. Okay. And this is the way we can write any equations. And here, of course, how to evaluate this, the implementation of the expressions using stack. And this is done by what is it? It's a reverse Polish notation. For example, you take the stack. So you just first the expression is converted into RPN notation, and first you read the instructions, maybe read from left to right. So while reading that expression, if any operand is found, immediately it will be loaded into the pushed into the stack. First 3, and next also 4. So immediately 4. Next, if it is an operator is found, then you make an operations using that operator, and the final results will be loaded into the against tag. So here is in multiplications, you just multiply 4 cross 3, and the answer is 12. You just place it into 12, and then after that, it is you just load the 5, then 6. Then you make an multiplications 30, and after that already is there. The last one is operator plus, then it is 42. This is a so the stack operations can be implemented through this, and RPN, this is used for evaluating any arithmetic expressions. Okay, and this is the stack operation.